A solid sphere, mass 1 kg, radius 1 meter, rolls without slipping. Rolls without slipping means at the point of contact with the ground, the relative acceleration would be 0 at this point. Let's call this point as x, the point of contact. And let this be the center of mass of this particular object, which is a solid sphere. Moment of inertia of a solid sphere about the center of mass, about an axis passing through this center of the sphere, would be equal to 2 by 5 mr square. Now, this solid sphere of mass 1 kg, radius 1 meter, rolls without slipping. That means relative acceleration at x would be 0, and that means a lot of things. And on an inclination of angle theta equal to 30 degree, on a 30-degree incline, two forces of magnitude 1 Newton each, two forces of magnitude 1 Newton each act on the sphere, both at a distance of radius equal to 0.5 meter from the center of the sphere. Taking g equal to 10, find acceleration of the sphere down the incline. That means you are asking about acceleration of the center of mass. If the center of mass acceleration is this, it must act at all points on this body. It should also act at this point. Acceleration of the center of mass at the point of contact should also act. And at the same time, if this is rolling and having an acceleration, angular acceleration alpha, then there should be a related tangential acceleration. Let's say AT is equal to the tangential acceleration. Tangential acceleration is equal to AT, should be equal to center of mass acceleration at point x, and then this will imply this thing, rolls without slipping, rolling without slipping. This is needed. Now dear, to get into the question, we need to calculate this acceleration of the center of mass. What are the things that are acting here? Say, for example, this entire thing has got a mass, has got a weight, and that weight is acting in the vertically downward direction. That means the component acting along the incline at the center of mass would be equal to mg sine theta, and therefore this particular force will, about the point of x, about the point of contact, will produce a torque, and due to which it will have an angular acceleration alpha. That means torque about the point of x is equal to mg sine theta as the force into the radius, and which is equal to capital R. Radius is equal to capital R is equal to 1 meter, mass equal to 1 kg of this sphere, of this solid sphere. So here we have this particular thing as a torque. Now is equal to I into alpha, of course. Now moment of inertia about which point, about the axis of rotation, which is at x. If you consider this point as the point of contact, then this force will produce a torque about this contact point, and therefore this should be I of x. But we have I of cm, 2/5 of mr square. Now from this, applying parallel axis theorem, I of x is equal to I of cm plus m into r square, and therefore this is equal to, let's say, how much? 2/5. The by value, this should be equal to 2 by 5 because m and r both are equal to 1 each, plus mr square, again 1. So that makes it 7 by 5 I of x, and therefore this is 1, this is 10, sine theta is half into r. This radius is equal to 1 unit, is equal to 1. This is 7 by 5, and this is, let's say, alpha 1. Let's say this is alpha 1. This is alpha 1 produced due to the weight. So therefore, this is alpha 1 is equal to how much? This is 5, 5 by 25, 25 by 7. radian per second square. Alpha 1 is equal to 25 by 7. Now, if we consider the forces that are acting on the body at these two positions at the distances of half a meter, each of them will produce torques. Now, that can be about the center of mass also. See, this can produce a torque about the center of mass, this can produce a torque about the center of mass. And if it is about the center of mass, then torques would cancel because these forces are of equal magnitude and are equidistant. Then it would produce zero torque about center of mass. But we are not dealing the question about the center of mass. We are dealing it for the torque about x, and that means now we have different torques to handle. Let's say the torque about x due to a force F will be equal to how much? This force is in the opposite direction, producing torque in the opposite direction. So minus F into let's say capital R plus small r. Radius being capital R. Let's say this radius is capital R, and radius, this much radius, this is the radius, and plus small r. And this particular force is producing torque in the same direction about the point x. Notice, about the point x is producing torque in the same direction. So plus F into capital R minus small r. But small r and capital R are related. This 2 times small r is equal to capital R. If you notice, where is the small r is equal to half a meter. Now that means this is equal to minus 1 Newton into 1 plus half means 3 by 2 and plus 1 into half. Effectively, this produces how much torque? This is equal to minus 2 by 2, that is equal to minus 1. Torque value is equal to minus 1, which is equal to I of x into alpha 2, for example. And now I of x is equal to 7 by 5. So minus 5 by 7 is the effective value of alpha 2 about the point of x. The angular acceleration about the point of x. These are the two angular accelerations. Now these angular accelerations generate alpha net. Alpha net is equal to alpha 1 plus alpha 2 by value. Total angular acceleration is the sum of these two accelerations, which is equal to 25 by 7 minus 5 by 7 makes it 20 by 7 radian per second square. This is, however, net alpha, net angular acceleration, but we require tangential acceleration, because tangential acceleration is equal to center of mass acceleration. So therefore, let's say we solve here. AT is equal to capital R into alpha net, and capital R is equal to 1 meter. Here it is equal to 1 meter. Again equal to, therefore, 20 by 7. This is going to be equal to 20 by 7 meter per second square. Meter per second square, and therefore this is going to be equal to the acceleration of the center of mass, 20 by 7 meter per second square. This is the answer of this question, and the reason is pure slipping, rolls without slipping. Thank you for your patience, and see you in the next question for more on physics. Stay subscribed, stay revised.